Hello, everyone. This is Professor Maloney, and today I'm going to be giving you a video recording on Unit 1. And I might also touch on a little bit of Unit 2, but I probably won't go there, okay? But for sure, I'll be talking about Unit 1, all right? So I'm going to already take the camera off me and share my screen, and we're going to go over to MindTap. And in MindTap, we're of course going to be at our class. Okay, so I'm sharing my screen. For today's video, I'm in section 5355. Again, what that means is this is the first class every Tuesday, Thursday. It is from 10:40 a.m. until 12:20 p.m., more or less. And the second class, so if you're in the 5677 class, yours is 12:30 until 2:10. But I'm not going to be talking about times for this video, because it's just going to be an overview. So I won't be, doing too much with any of those things there. So I'm just going to go ahead and let me actually verify that I am sharing. Okay, I'm sharing my screen and I'm sharing video of my screen. All right, so I'm going to go to Student Start here, and then Students click here. Now everyone is in the class by now, or they're out of the class. Okay. All right. So, come on. All right. Now, remember, in this class, we're doing 8 units. Unit 1, Unit 2, Unit 3, Unit 4, Unit 5, Unit 6, Unit 7, and Unit 8. All units, with the exception of Unit 1, will include programming code assignments. As I said, on both days during week 1, there are 41 programs you have to do in this class, and that doesn't include the 3 exams, which are all based on, well, which are not based on, they are programs. They're all based on the units. Yes, the first exam is based on units 2 and 3. The second exam is based on units 4, 5, and 6. And the third exam is based on units 7 and 8. Where do you go to find these exams? In terms of the times and the days. Well, you click your schedule, syllabus and tentative schedule of activities. And if you open up your syllabus document, now remember here I did say this is for 5355. So those of you in 5677, you just substitute the times for your class. So first exam, exam 1, units 2 and 3. It's going to be taken at the MindTap site, and it is only available during our required live class hour session. Okay, it'll be on Tuesday, September 27th. It'll start at 10:40 a.m. and go until 12:20 p.m. So what that means is at 12, if you start at 10:40, technically at 12:19 and 59 seconds, it's over. It doesn't let you hit 12:20. Once 12:20 is there, it's over. So that's what happens. Now, if you're in the 12:30 until 2:10 class, yours will say 12:30 p.m. until 2:10 p.m. And the same thing, at 2:19 and 59 seconds, it will end. And if you don't have the file uploaded, it won't let you upload the file. Okay. If you beg me and I let you, there'll be an automatic 20% penalty. So it is not worth getting a 20% penalty to be a second or two or a minute or two late. So please be sure to adhere to these requirements. I'll talk about this a lot. But anyway, so Tuesday, September 27th. Exam 2 is this one here. Again, it's the same times, so 10:40 a.m. to 12:19 and 59 seconds for the first class, and that's Tuesday, November the 8th. For the second class, the late class, it'll be 12:30 until 2:19 and 59 seconds. And finally, Unit 3 exam is from 10:40 to 12:19 and 59 seconds on Tuesday, December 13th, which is exams week. So if you're in the late class, it'll say 12:30 until 2:20, which is 2:19 and 59 seconds. All right? All right. And I won't review this again. So make sure, I will to keep you apprised as to, hey, the exam is coming up next week or tomorrow, that kind of stuff. But I won't be going here every day. And remember, you can also look at all the assignments that are due the day before, really the night before the exams. So in the case of exam 1, it's again on Tuesday, September 27th. So all of your assignments from units 2 and 3 are due on September 26th at 11:59 p.m. Assignments are always due at the end of the day, last minute of the day, all right? And they would be chapters 2 and 3, programming exercises 2-1 up until 2-6, and 3-1 up until 3-6. That's a total of 12 programs, and also 2 quizzes. You can do each program twice, by the way. Each quiz you can do twice. So you have 14 assignments up until that time, all right? Okay, now, having said that, remember too that the MindTap site has all that information, right? So if I click on the same units, so unit 1, if I click on, well, unit 1 doesn't have any code, but for the first exam, it's units 2 and 3. So unit 2 code, it'll all say it's due September 26th. It has 0% here. That means nobody has started it, but it is available, okay? It is available. In my other class, just to let you know, one person has completed all 6 chapter 2 programs. Staggering, but he or she has, one person. And then unit 3 up here will also be all due on September 26th. All right, that is that. All right, now, but in addition to that, there's the unit 1 quiz. This one is due, you'll be seeing this video on Tuesday, August 30th. And the quiz, unit 1 quiz, is due September 7th. Again, you get it to do it 2 times. It's the only graded activity you have to do for unit 1. There's no unit 1 code, but for all the other units, there's code. And code is where most of the assignments are. All the orange filled in bubbles are your assignments, as you know. Okay. And there's that unit 1 exam on September 27. And then unit 4 stuff is all due on November 7th. So all the code the same way. And unit 5 and unit 6 the same way. And then the unit or the units 2 and 3 exam, that one is November the 8th. Again, just like the syllabus shows. All right. All right. Now, so collapse all. Now let's look at the unit 1. All right. So all you have to do here is a quiz, and each quiz is worth 1% of your final class grade. There are 8 quizzes, one from unit 1, one from unit 2, etc., up through unit 8. So each quiz is worth 1%. So cumulatively, all 8 quizzes are worth a total of 8% of your class grade. So making a silly assumption, but if you decided not to do any of these 8 quizzes, you got a 0 on all of them, you could still make a 92% in this class. And of course, to do that, though, you'd have to make 100 on every programming exercise, so all 41 of them. And you'd have to make 100 on all 3 of your exams. And you'd have to make 100 on your bio post, which you can't post anymore because today is 8:29, but you'll see this on 8:30. But I told you last Tuesday, the 23rd, on day 1, and I told you on the 25th, day 2, that the bio post is the one thing you cannot submit late. It's only worth 2%, but that's 2 times as much as this quiz. Anyway, all right, so far, 6 of you have submitted the Unit 1 quiz, okay? 6 of you. And the average score, 92.5%. That's a wonderful average score, right? So that means a few people may have made higher. Actually, a lot could have made higher. Well, not a lot, because there's only 6 of you. But, you know, a few of you could have made higher and a few of you lower. Or perhaps 4 or 5 of you very, very high, and perhaps 1 or 2 a little bit lower. And if it's only 1, maybe 1 very, very low and everyone else very, very high. But bottom line, 92.5%, that's an A average, and of course that's what I expect in this class. All right, so what do you do to prepare yourself for Unit 1 quiz? Well, obviously you have the Unit 1 read. So there's a preview, and the preview here covers these 8 items. Now, you will not, there's no programming things that will be done in this class identified in Unit 1, none. Okay, so summarize the history and evolution of programming languages. It's irrelevant in terms of anything you're going to be tested on, but the quiz is, like a light scale test, and the quiz is what you'll be doing this stuff for. Okay, so identify the elements of computer hardware, software, operating systems, and languages, distinguish the components of machine language, define the processes of a C++ program, list the steps in problem analysis coding, differentiate programming methodologies, compare programming languages, and define ANSI/ISO standard C++. So these are the things in the book, but this is the least important book in a chapter in this book, because everything has to be done you know, in the other units, also the other 7, there's a total of 41 programs. There's 6 programs from chapter 2, 6 from 3, 6 from 4, 6 from chapter 5, 6 from chapter 6. There's only 5 in chapter 7, and then there's 6 again in chapter 8. If you add all that up, that's 41. All right. All right. So I'm not going to talk about it from here. I'm just going to show you though what else. So that's the overview, right? And then your unit 1 read, you can click here and it comes up in full page. So you can do that, or you can just come to the full book over here on the right side of your screen. It's up to you how you want to do it. But you'll notice there's like a quick review. So if you go to the quick review, these are things, for what we're basically doing here. This is good enough. And by just kind of talking about them in this way, it'll be relatively easy for us to get through this. So I'll just do so that way, okay? So what is a computer? Well, obviously it's an electronic device, and the electronic device is what we use. It's capable of performing arithmetic and logical operations. So what does that mean for us? Well, we're going to be using C++ in this class, and we're going to be doing arithmetic operations. Arithmetic operations obviously mean math, but we're also going to be doing logical operations. Logical operations are when we're using like decision structures. We're using if statements. We're using select statements. These are programming statements that allow us to code our program to be able to go in different places depending on what the answer of the question is. As an example, let's just think, what if you're going to be voting, or you want to vote for, so the Democratic primary, I'm a Democrat, by the way, and the Republican primary, I assume the Republican primary also just ended, but most of the coverage was on the Democrats, not because it's the media showing preference, but because obviously the Democrats have to challenge the Republicans in the state of Florida. So we had all the Democrats fighting amongst each other. Then they went and had the primaries. Now those are over. So DeSantis is the Republican incumbent governor, and he's going to be going against Charlie Crist, right? You've got that guy, whatever his name is, from Miami. He's going to be going against Val Demings, Marco Rubio, etc. Right? So how do they determine whether you're able to vote? So let's consider that in terms of using logical operations and if statements logic. So for you to be able to vote, you have to be 18. So we probably want to put some kind of an if statement logic in our program to say something to the effect of, if, and of course we need to have a variable representing your name, or a variable representing the number you put in the age text box. And of course the text box is what? It's an area where you can put information into the screen. In our case, in this class, we're going to be using the command screen. We're going to be using command line output. So we're going to be using the screen itself for output, and also using it for input. So we're going to be basically using what we call COOT statements. COOT statement is really, it stands for C output, okay? And then SIN statements, that's C-I-N, that's C input, all right? So when we want to get information from the user, we use CIN statements. When we want to give information to the user, we give COUT statements, all right? So we'll be coming back to this, but that's how we do arithmetic and logical operations. So computer systems have 2 components, hardware and software. Well, most of you know that, obviously. Hardware, that's things that are physical, right? So if it's a big desktop computer, your case is obviously hardware. All the wires, all the switches are hardware. The monitor is hardware. Okay? If you have a printer, that's hardware. So what's software? Well, there's 2 kinds of software. There's operating system software to run the computer based on its operating system, and there's application software, and application software is based upon what you're trying to do. So when we're looking at anything in this class, we're going to be dealing with, in terms of you seeing things based on software, PowerPoint files, right? So there's a PowerPoint file for Unit 1, and I'm going to be showing it to you, but I'm doing this from this quick review area. And of course, there's the e-book. That's sometimes, they use things like card readers and stuff, so you can actually have that book read to you, right? Depends on what kind of software you use. But application software, and then of course there's operating system software. So if you're using an Apple, if you have a MacBook Pro or something, then you're using a Unix operating system. I have a Windows computer, so of course I'm using a Windows operating system. There are also Linux operating systems. So if this was an A+ hardware or A+ software class, which I teach those as well, but I'd be dealing with those things. That would be the important thing. But for our class, it's not important at all. But it's very, very possible you're going to have some quiz questions on all these things here. All right. Okay, so that would be hardware and software. And then there's the CPU. The CPU is called the brains of the computer, right? It's the brain of the computer. And then main memory is something that a lot of people get a bit confused about, because when you turn your computer off, there's nothing left in main memory. The only way you save things in your computer is to your hard drive, or of course to an external device. What do you have for external devices? A lot of people these days are, of course, jump drives, right? But a lot of people also store things on the internet. Store them at, let's say, Box. Store them at Dropbox. Store them on OneDrive. Store them on the iCloud. Store them on, wherever, right? So it's just what we do these days, and it makes life much easier for us. But the CPU is the brains of the computer, so it's what makes the computer tie everything together. It's based on a whole bunch of other programs, but that's the nature of the beast in terms of using computers. And the hardware components I just mentioned. So all programs must be brought into main memory before they can be executed. But again, once main memory is off, it's over. So as an example, for you to run a PowerPoint file, the PowerPoint file has to be loaded into main memory, okay? And then as you're hitting the save button periodically, or if you have the autosave ability built in and you're taking advantage of autosave, then your work is being saved every 30 seconds or so, but it's not saved in the main memory. It's saved wherever your secondary storage is, a jump drive, one of those external, cloud-based places to put your files, right? So when the power is switched off, everything in the main memory is lost. Secondary storage is where the permanent storage is. Again, normally we save things, if it's on a desktop computer or a laptop computer, we save things, on the computers. A lot of people have a very messy desktop. Let's see how messy mine is today. There's mine. What was I doing with my calculator? Who knows, but let's get it off. So that's mine. Now, of course, if I want to say, hey, wait a minute, let's personalize this thing. Where in the heck is my personalization here, right? Oh, I want a theme? No, but I want a background image. Let's see, where's my background image? Let's see. I don't want Windows Spotlight. I want a picture, don't I? Yeah, I want a picture. And it should be a family picture, right? Right, so picture, where am I at here? Picture. Oh, and then I'm going to browse to find my picture, browse my photos. Now, I don't use anything from my typical desk place. I'm a little bit different. So I go to this PC just to show you what you can do. And then I go into my users, okay, C drive, and then my users, and then me. And then in here, I have my pictures, okay? So pictures. And this is the one that I think I showed you guys in class. So this is one of the ones that we took in Toronto recently. And then if I shut this thing down, now you see the desktop with the picture I believe I showed you guys in our bio posts. All right. This is the young man, my oldest son, Jared, that's moving to Canada on very, very soon. On September 7th, we're moving him up there. His swearing in ceremony is September the 9th. And my wife, Eva, and my son, Caleb, and I will then be flying back home from Toronto on the 11th. But Jared, after swearing in on the 9th, they're then flying him over to Montreal and then putting him in a cab to take him to Saint-Jean-sur-Richelieu in Quebec. Quebec is French, and that's where he's going to be stationed. But he won't really be stationed there in a permanent way, because he's going to be a Marine Systems Engineering Officer, I think I told you. in the Royal Canadian Navy. So he'll be stationed either in Halifax, Nova Scotia, which is on the Atlantic Ocean, or in Victoria, British Columbia, which is on the Pacific Ocean. Anyway, all right, so we have that, right? All right, now let's go back to wherever the heck I was. Sun here. All right, so anyway, when the power is switched off, everything in main memory is lost. That's the way it goes. Secondary storage is where we want our files saved. All right. Okay. Input to the computer is done via, an input device, of course. Two common input devices: keyboard and the mouse. Right. Keyboard and the mouse. And then computer sends the output to computer screen or a printer. So in our C++ class, we're going to be using the computer screen as our output. All right. And of course, our input is going to be done via the keyboard. All right. All right. So software programs run by the computer. You may say, well, so I'm running C++. Yeah, we're running C++, and C++ is a program that is being used at either the MindTap site, because the MindTap site can run C++ programs. They have a compiler which translates all of our source code into executable code that we can then see. And I also gave you guys, I think I gave you a homework assignment, because I didn't have time to play video number 2 in class on, or video number 3, sorry, in class on Thursday. So I said I have a 30-something minute Replit video for you to create an account on the Replit site. All right. All right. So software programs run by the computer. Operating system handles the overall activity of the computer and provides services to us. The most basic language of a computer is a sequence of zeros and ones, and that is machine language. Every computer directly understands its own machine language. So machine language is used at what we call the physical layer of the 7-layer OSI model. OSI stands for Open Systems Interconnect. This won't be on your test, but it's just general information on your computer. So, but the computer itself on the basic layer, which is layer 1, the physical layer, is all a bunch of zeros and ones. Okay, machine language. Every computer directly understands its own machine language. And then we have to make, so the computer understands zeros and ones. A bit is a binary digit, and again, it's either 0 or 1, but the smallest amount of information you can store would be in a byte. And a byte, B-Y-T-E, byte that is a sequence of 8 bits. All right? So if, as an example, I wanted to type the capital letter A. Well, a capital letter A, again, I teach A+ hardware a lot, A+ software a lot. Well, really, actually, I don't teach them a lot anymore. I haven't even taught them in 2 years. But a capital A in the ANSI world, the American National Standards Institute world, is either a 65 or a 66. So let's say type here, capital A in ANSI. Let's see if it's 65 or 66. So let's see, here's all of them. Let's click this one. Go to 60, 60, 60. 65 is a capital letter A. Okay. So if I wanted to do the capital letter A for you in turning it into a byte, you can just create here a new file here. File new. Do you want to save? No, actually, no. Cancel that one because I'm not going to. That's what I'm still using for the video I'm creating today, and I'll be using more. But let's see this one. This was a Zoom library. Yeah, I'll do this one. All right, so file new, and yes, I want to save that one. So A equals, all right. So it would equal a 0, a 1. Let's see, 60. Did I say 65 or 66? So 65. All right, so 0, 1. And then a 0, a 0, a 0, a 0, 1, 2, 3, 4, 5, 6, a 0, and a 1. Now, let me tell you how this works and what it basically does, all right? All right, so in the computer world, all right, we have a 128, then we have a 64. We always start at the high number and go down to the low. Then a 16, then an 8, then a 4, then a 2, then a 1, all right? So if you notice, that's 8. 1, 2, 3, 4, 5, 6, 7, and 8. If you add these up, let's see the big number you get. 3, 7, 15, 31, 63, 127, and 128 is 255. And 16 squared, which is the F in hexadecimal, is 256. Technically, they don't count 0, but 0 does count, so it is 256. All right, but that is that. And now, how I did it here, what you then do is you go now, this is called the most significant bit, and this is which one it is over here, the most significant. This is the least significant, and that is over here. So you take where I have zeros, it's zeros below. So 0. This is a 1. This one is on. This one is a 0. It's off. This one's 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 on. It's a 1. Now, this 1 is under 64, and this 1 is under 1. So equals, I should do 1 equals, otherwise people get confused, equals 65. Okay? So A is 65, as shown here on the screen, 65. All right? It's kind of complicated, but it's not a big deal, a big deal these days. But in any event, that's what that thing is. All right. So back to our file. Where am I? My tab. All right. So that's that. A byte is a sequence of 8 bits. I just demonstrated that. A sequence of zeros and ones is referred to as a binary code or a binary number. That's what I also referred to. This here is how we get to numbers. So basically, I just said 8 bits equals 1 byte. Well, 2 to the 10th power is 1,024 bytes. Okay, so what that means is this. Let's go back to the same notepad file. And again, you don't need to know this though. So let me just say here, 1 byte equals 8 bits. 8 bits. All right. Now I'll go over here and say for the next one, what's the next higher one? It's 1 kilobyte. 1 kilobyte. 1 kilobyte equals 1024 bytes. So what that means is we say 2 to the 10, which equals 2 to the 10th power. I was in Word, I could do subscript and superscript, but I'm in a notepad file. All right, so that is that. Now, what does that basically mean? It means, watch, if I do 2, what's 2 doubled? 4. What's 4 doubled? 8. What's 8 doubled? 16. What's 16 doubled? 32. What's 32 doubled? 64. What's that doubled? 128. What's that doubled? 256. What's that doubled? 512. What's that doubled? 1024. Now, if you count that, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 to the 10th power equals 1024. All right, that's that one. Now, the next one they're saying is 2 to the 20 equals that big, huge monster of a number. So let's just, we already have 10, all right? So let's go now. So 1024, again, equals 2 to the 10th power. Now we'll go, if we double that one, I'll skip a space. So 2048, if you double that, 4096. If you double that, that's 8. That's almost 200. So it's 81, and it's 8 less. So 8192. Okay, so that is now, it was 10. So that's 11. That's 12. That's 13. So 14 is 16. And then you double 1 is 2. But you got, well, 92, 92 is 8 and 8, 16 left. So it's 16 less than 16. 400. So it's 16,384. Okay, I may be off, of course, by the end of this, but it doesn't really matter. So this one, 32,768. This one, 64. So it's now 65. 7 is 14, but it's going to go higher. So it's 15. 16 and 6 and 6, 20. So it's going to be 30 and 16. I think it's going to be that. Obviously, I will be wrong at this, but now I'm at 2 to the 11, 2 to the 12, 2 to the 13, 2 to the 14, 2 to the 15, 2 to the 16. I want to just get to 2 to the 20. So 65 and 65 is 130, but it's 5, so it's going to be 131. And that part's going to be all right. So it's 72. So 131, 72. Okay. Double that one. We're at 263. and then 44, I think. Okay, 263. Wait, I'm missing numbers? That's 5. Yeah, it's, wait a minute. No, something wrong. No, it's something's wrong. That, well, we'll see. Anyway, let's see. 16,000. No, I'm missing. My God, 32,000. This is 65,000. Shoot, silly me. This is 131. I'll just put zeros at the end. Make them all that way to make it easy. But so that's now, yeah, 260 something. That makes more sense. So then it's going to be 527 more or less. You know what? I'll even round them this way now. So I'll just say 527. And then this one is going to be the next, this one less. So 527, that would be 1054 more or less. 50 that. And then that means the next answer would be the next one. So 11, 12, 13, 14, 15, 16, 17, 18, 19. Actually, it's that. So it's this one. So 105. Oh, no, I need another 0 now. So it's it's this. So it's more or less this. Okay, let's go to look at the cheat sheet. Cheat sheet is them. 2 to the 20. Right there. 1048,576. So 10, that should be 48,576. So I'm not even 7,000 off based on 1,054,000. I think we can forgive me for that. So that's equals 2 to the 20th power. Okay, and let's go ahead and put the actual. So it's 1048,576. 1048,576. So 1048,576. All right. So that's stuff that if you're in A+ hardware or you're in networking essentials, A+ hardware is CTS 1131. A+ networking, networking essentials is CTS 1134. That's the kind of stuff you learn a little bit, but these days not quite as much as in the old days. And then if you want it, you could easily go to the same numbers. Obviously you don't do it by hand anymore, but the point is this, right? It's logic. So it's all 2 based, because our system here that we're talking about is bits and bytes, and that's the 2. This is called base 2, 0 and 1. What we use is base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the third system is base 16. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10. And then after 9 comes capital A. That's 0 through 9 is 10. So capital A is 11. Capital B is 12. Capital C is 13. Capital D is 14. Capital E is 15. And capital F is hex for 16. All right. All right, cool. So that's that stuff. All right, so now we have these languages. So assembly languages use easy to remember instructions called mnemonics. Mnemonics are things that, like you guys with your SOS, your LOL. For me, IT. So things like that. There's that programmer, something, and something, I can't even remember it. But anyway, mnemonics are just things to help us remember things easier. But what we need to talk about is in terms of the assembly language. So the assembly language uses mnemonics. Well, what is a real example of mnemonics? Well, it would be like load. All right. So when we used assembly language, and when we use assembly language, I guess I should say, not many people do it, of course. You'd do things like load, and you'd load a memory address. And memory addresses are typically done in the hexadecimal system. So it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F, all in caps. And so you may have a memory address of 1, 2, 3, capital A, 6, 8, capital D, 4, 2. That could be a memory address, right? And it can store billions and billions of characters. But so that's what we do. Assembly language in the old days loads information, and the information it loads is data, okay? So that's the assembly language. But then we need an assembler, and the assembler is what we use to translate the program written in assembly language into what's called machine language, okay? Machine language is commonly called object code, and machine language is what we end up using to move us closer to the executable code. So after we have our machine code, then we have to go ahead and have a compiler translate the program in in our case, it's going to be into C++, but it's any high-level language. And we're using the MindTap site, and the MindTap site has the most popular compiler used, and the Replit site also uses the most common compiler in use today as well. So we'll use compilers, but they're built into the programs. So when you're doing a program at MindTap in this class, meaning if we go over, I'm in here, so I can't do it right now. After I finish the quick little overview here, then I'll quickly go over and show you, going where you are. And I think on last Thursday, the second day of class, I showed you where you click to find your programming exercises. And it's in the Unit 2 code, and then Unit 3 code, Unit 4, Unit 5, Unit 6, Unit 7, and Unit 8. I said Unit 1 doesn't have any code, all right? But anyway, so after the compiler, what it's going to do is it's going to transfer or translate the program from C++ into object code. And then we need a linker file, and the linker file takes that object code, and then it uses a file that's built into the IDE of the program you're using. That's the Integrated Development Environment. A big popular one these days is Visual Studio, but any integrated development environment for that. And then there are 6 steps basically to execute the program: edit, pre-process, compile, link, load, and execute. Okay, so that's more or less it. Loader transfers the executable code into the main memory. That's when we then see the results. So when we run a program, the loader is what's going to throw it into the language we can see. Then algorithms. They're step-by-step problem-solving processes in which a solution is arrived at in a finite amount of time. We'll talk maybe about a program today, but in things like this, a problem-solving process as opposed to in C++. All right? And then the problem-solving process has 3 steps. Analyze the problem and design an algorithm. And again, the algorithm is just something that is just a word to represent a step-by-step process, okay? We would implement the algorithm into a programming language, but the algorithm itself is not written in a programming language. It's us just writing down things. As an example, let's say I want to take that thing I said a little earlier about the election that's coming up. So we would want, if you had a program, or you wanted to write a program to check if the person is old enough to vote, so you'd have to have a input field asking the person for his or her name. You might need to have some identifier like a social security number. You might need to have, well, you would definitely need to have their birth date, okay? And then we would figure out, okay, is, and that is again logical. It's using if statements. So it's using a value that's called Boolean. It's either going to have a true or a false. In other words, is your birth date minus today's date enough for you to be, or today's date minus your birth date enough for you to be 18, right? So if the answer is that you are 18, then yes, you can vote. But there's another thing, you must be registered. Did you? So then you'd have a verification that the person sent in their voter's registration. You have to be at a particular, what's it called? Voting, God, I vote them all now, but nowadays online. But we'll just call it polling house, but you're registered at a station, and they can then verify your name. And if you're there, those 2 things have to both be true. And then we'd have an else. Well, if you're not 18, sorry, you're not old enough to vote yet. That would be a nice simple reply. But if yes, you were old enough to vote, but then there's the if about the polling station. But your polling station says you have not registered, or you're not registered yet. And then something to the effect, we'll send you a registration form. So, I mean, that's like an algorithm. Okay, that's an algorithm of what people do. But in the programming world, we take algorithms and we throw it into code. All right. So let's get out of this one now. I want to go back to the real book, though. Let's see over here in our book. Oh, shoot, messed up. I actually want to go back there. Let me get out of that. Sorry about that. I'm going to go back over there one more time to see if they have any of the examples. any example code. Let's go in here. Because for Unit 1, I won't be demonstrating code, but next class, I'll have a little example from Unit 2 for you guys. All right, I'm going to open the book, the full book, and I'm going to make this the whole screen just to see. So table of contents for Unit 1. Exercises. Let's go in here. All right, so let's see here. Mark the following statements as true or false. Calculating device called Pascaline could calculate sums up to 8 figures long. All right, so these are not what I want. I want to show you machine language is a sequence of ones and zeros. Okay, binary code is a sequence of ones and zeros. Sequence of 8 bits is a byte. Okay, so some of these are good. 1 gigabyte is 2 to the 20th megabyte. I'd have to calculate that, but after megabyte, it's gigabyte, so it'd probably be 2 to the 10. But again, in ASCII, that's one I just showed you, is the 65th character. That's true. Number system used by a computer, that's base 2, that's true. But anyway, you know, some of these, whatever. But I'm looking for other things. What do they have in here for design an algorithm? There you go. So design an algorithm to convert change given in quarters, dimes, nickels, and pennies into pennies. So how would we do such a thing? So we can say someone gives you 10 quarters, 10 dimes, 10 nickels, and you want to know how many pennies you have. What would you do? Right? So the algorithm would be this, okay? And we would then have to figure out, well, how many pennies is in a quarter? How many pennies is in a dime? How many pennies is in a nickel? We know how many pennies are in a penny, okay? So we have to know that. And then we'd need to declare variables to represent that 1 quarter equals 25 pennies, that 10 dimes equals 10 pennies, that 10 pennies equals 1 dime, and that 1 nickel equals 5 pennies. And then we have to figure out how many quarters did the user say he or she had. So if they have 3 quarters, and we know there's 25 pennies in a quarter, we have to then multiply 3 times 25 to get that number of pennies, right? So if it was 3 for quarters, that would be 75. If it's, let's say it's 3 for dimes also, so that's 30. So 75 and 30 is 105. And we'll say it's 3 here as well. So there's 3 here. So 25 times 3 is 75. 10 times 3 is 30. 75 and 30 is 105. And 3 times 5 is 15. So 15 and 105 is 120. If I did that right, is 120 pennies, okay? But that's an algorithm in the real world using what we call natural language. So what would we need to do? So we would need a variable to represent. It'd be called a constant. How many pennies are in a quarter? Need another one? How many pennies are in a dime? And another one. How many pennies are in a nickel? So we have 3 variables just right there, okay? 3 variables. And then we have to get information from the user. How do we get information from the user? Well, most of you should not know this yet, okay? But you know what? We're going to do this thing here. Let's just go ahead, and it may take longer now. So we did that. Let me, just in case somebody in class asks me whatever, I'll just put this down here. All right. So, and I demonstrated that. Can I copy that thing they have here? It's a PDF. I'm not sure. Where's the darn thing? Okay, this. Yeah. Okay, this. So that. Control copy that. Here, this one. All right. So Control V that. All right. So we need to have variables. We need a variable, and I'll put in parentheses constants, for, I'll do it this way. I'll say, so this would be, I'll say int quarters. Okay. Oh, and if I do it as a constant, I have to say it this way. So constant, C-O-N-S-T, int is the data type, quarters, and then equals 25 and a semicolon. Okay. Then I need constant, int times equals 10, okay, and that. And then constant, int nickels, I should say quarter, because we also want to use the same value when we're getting the information from the user, we'll say. So nickel equals 5. All right, so constants never change value. Okay, if I put over here slash slash, remember slash slash is a comment. So I'll say here, constants never change. Constants never change. All right, constant value, in other words, never changes. So that would be the same for the 10 and for the 5. All right, so then though, we need input from the user. So let's say, and let me do it with my way. So my way is this. I'd say step 1, declare variables. Okay. Variables. All right, so that would be step 1. But we need more variables because we're also going to get input from the user. So then these won't be constants. So now I'm going to say int quarters, right? That, and then int dimes, that, and int nickels, that. All right, so they're still variables. Now you could do int quarters, comma, dimes, comma, nickels, and then semicolon. Okay, so you can do it this way, or you can do it the way I did it at the beginning. If they're the same data type, you can put them on one line, separate them by commas. You need a semicolon at the end of a code statement. So if they're separate lines, they have to have semicolons. All right, so now we have done our variables. So now step 2, assign values to variables. Okay, so we already have values on these that are constants up here. So we have values, but we need values from these. All right, so we're going to do that by sending COOT statements to the user, and then using SYN statements to get information from the user. And again, SYN means C input, CIN. All right, so here we'll say that, say COOT less than, how many quarters do you have? Excuse me. So I can say, how many quarters do you have? And then I can go here, if I want to, I can say less than again. Then I can say this and a backward slash n to have a new line, and then this, and then this. That would send them automatically to a new line. It's a little early in the class for this, but that's okay. But it does end in a semicolon. All right, so now what I'll do is copy this one. So control, copy that, and now control V that, and then put something in between it, and then after it again, control V that. And now here I want C input statements. So C input greater, okay? And now what are we going to get? Well, for quarters, we're going to use this one. So we're going to say SYN greater, and then quarters. All right, so that. All right, so SYN for quarters, and then for quarters, for quarters, and then here, how many dimes do you have? Okay, so here, same thing now, copy that. You don't have to do it this way, obviously. There's lots of ways to do things, but that's what we're doing is just trying to do the program that they just showed us this way. And then how many nickels? How many nickels do you have? Then again, let's see, I think I'm on the CIN, yeah. And then here, nickels. All right, so now we have asked the user for how many quarters they have, and we put quarters. We want the plural, not this one, because this is a constant. What we're going to then do is multiply quarters times quarter. So we also need another int for pennies. Int pennies. This is the one. Convert quarters, dimes, and nickels to pennies. All right. Okay. So then let's separate that with a space again, then come down here. So that's that. Then step 3, my philosophy in life, step 3, do calculations. Okay. So what's calculations? So we're going to say pennies equals quarters times quarter plus times dime plus nickels times nickel. Okay? That. And then we have our answer for that. So quarters times quarter is taking what the user tells us he or she has here. Their value is quarters, okay? And we know a quarter represents 25 pennies. So we need to multiply their number times that 25. You don't say by the number, you put the variable, and that's quarter, all right? So it's like this. And sometimes you do have to use open and close parentheses. So quarters times quarter, okay, plus dimes times dime, plus nickels times nickel. Okay, that would be that. And then step 4, step 4, output, and I'll put and format, but at this point in the class, we're not doing that. Output results. Okay, so that would be coot less than, you have that at that pennies at that space pennies and that. All right, so that would be that. Now, so let's just take this. So design an algorithm, that's a comment too. So I'm going to take this for now, okay? Take this, go down, whoops, I don't want all that. And then that, okay? Remember, they have a lot of the code for us, okay? So I'm going to take this. So I'm going to control copy all this, all right? Go into your mind tap, let's say. All right, so let's get out of here. Go into your program. So when you want to play, you go to unit 2, okay? Well, you really should do it at Replit. Actually, you know what? Let me do it at Replit. I'll show you how you can do it here too. So here's 27, 28, 29. It doesn't matter. Let's just click on 29. Anyone that doesn't have an orange filled in bubble, remember, is practice. It's just play. So now this is not going to grade this assignment for me though, because the assignment is going to be on the left-hand side. Let's wait till it pops up there, all right? All right, so I'm writing a program that prompts the user to enter 5 test scores and then prints the average test score. I'm not going to be doing that. But what I want to do is put all my code up there. So I'm going to first do this. Go down here, Control V. All right, now, so all that stuff up there that I need, I'm going to put in here. Right where it says write your main here, above the return 0. So this is, see, I've already got the IO stream, right? Remember your IO stream? That's the preprocessor directive for the library that you're using, okay? The namespace std, the using, means I'm using this particular namespace, and this one with std, as I said and demonstrated actually. I went to either MindTap or Replit last week to show you what you, like if you want to do a coot without namespace standard, you had to do std : before the word you were going to use, meaning in this case coot. Anyway, so I got this here. Let me go ahead and have quite a few spaces just in case I have a little mess up. All right, so in here, now I have my me. So I put a comment, design an algorithm. This one here I'd really put on top. Okay, this is what I'm doing. So I Control X that one, and then go to the top. I'd put that above there. I'll be asking you guys to put comments a lot where you put your name up there and the date and whatever else. But anyway, so that and that. Okay, so now write your main here. So I just took that part. So now this is the main. Where's my, oh, right here. So all these things here, all the way to here is the main. So let's Control Exit just to make sure where I am, and then put it in here. So this is, remember, a comment. So now I'm typing it in. And now it's all in. But let's not even look at it. Let's just run it and see what we've got. Whoa, we've got some does not name a type. Let's see what we've got. All right, so that's line 61 with a 1. So 61. Oh, what the heck did I not do? What in the heck did I do? You have. Thought I cut it. Just in case I need this, I'm going to cut it again. So Control X. That's definitely gone. Okay, now let's run it one more time. Okay, so now there's still some issues here, all right? No such file exists. All right, so let's see what we've got here. So no type, name type in ST in a structure. So let's see what I've got up here. Oh, I've got my pound include IOStream. I'm okay. I've got my using namespace standard. I'm okay. So I'm in my int main. I like to make sure that I move this opening curly over here. Write your main here. So I've done that stuff here. So let's see here. Let's go to start on the bottom and then I'll work up. So line 29, it says 23rd space in, suggest alternative quarters. They don't like, this is not an error, but they don't like quarters and quarter. They don't like nickels and nickel. But that's still not problem. Here I do have some problems though, so I have to find out some of this stuff. Let me move this over. No type named again. So there's something weird here in our little system. Template argument, deduction, substitution failed. In substitution of template class, there's no error really. It's just this thing here. User include C++7, iStream 980. See, 980 is not even going to show because that's not in mind. That's like at the compiler level. That's at the compiler they're using. And they're saying there's a problem there. So let's see here. Let's just fix everything without not looking at that because I'm a teacher, so it doesn't really matter. All right, so what I'm going to do is start with one COOT statement. So I'm going to go from here /*, which means I'm starting a comment. I'll go down to here, */ to say my comment's over. I want to see if this much of my code is okay where I just ask one COOT statement. How many quarters do you have? So let's see if that would work. No such file or directory. What is going on? Now, it's possible, actually, it's based on what they're expecting. But I don't think so, because that's not normal. They don't normally do that. They let us use these. So let's go again. Let's go again. So let me see. Main. Where I'm in my main. And there's my opening curly. Let's go ahead and close the curly. Closing curly is down here. So that's perfectly fine. That's a comment. That's the start of the comment. Everything else, that's a COOT statement. So less than, ask the question, opening and closing. And then I'm just putting this, that just basically means new line and a semicolon. This is a comment, so it doesn't matter. These are just variables. As long as they all have a semicolon, they're fine. There's nothing wrong with any of this. We need a variable for. So constant int quarter equals 25, that's fine. Constant int dime equals 10, that's fine. Constant int nickel equals 5, that is also fine. Semi. And I've got my pound include, I've got my using namespace. There is just nothing wrong with this code at all. That's the bottom line. Now, let's just play again. So now I'll move my, I'll just get rid of it there and go up higher. Okay, let's see here. Put it here. I'll put it here. ***. So now the beginning of the comment is there. So now I'm just going to basically do a different one. So now I shall just say, let's see, string f name that. All right, so I've got a string f name. And so COOT less than. Please enter your first name. That. Okay. That. And then C input, greater, F name. When you see your variables pop up, you can double click them if you want to. Make sure you put a semicolon at the end. So we're asking the person for their name. We're entering what they put in. And then for output, so again, step 1 is the variable. We have it, okay? So we have that. And then here, step 2, assign value to variables, and that's what we're doing in that. And then step 3, do calculations. We're not doing any. And then step 4, Say results. And then that's going to be another coot, less than. Your name is that. Your name, oops, your name. Always put a space, by the way, so that the name doesn't butt up to this word S. Okay, so that, and then less than, and what's the variable name? I put F name, just double click on F name or just single click on it, semicolon. Run this. Okay, yeah, there's a problem here. So let's see here, 9. Here have comment. Okay, so run again. Please enter your first name. So if we say Ted, okay, and we enter, it says your name is Ted, all right? So if you want that to go to a different line, then what you can just do is do this and then less than, and then do a single quote, a backspace, a backslash, a single quote, and then again, get rid of the extras that they're giving us, all right? So that, or slash N for new line, okay? And run it again. Enter your first name, Ted. Now it enters Ted and goes to a new line. All right, so that code there is exactly the same as this code here. So what I'm going to do now is take this, and this, okay, put that one up there. Control copy. Did I make that as a, it's not commented out because the slash asterisk is there. So I'm just going to do this here. So that's my step 1 with my variables. All right, so here's my step 1. I'll leave that one there. I'll still do it that way. So the first one will still be F name. But anyway, that's there. Okay, so now let's run it again. There's nothing code-wise in it. So they're saying warnings because they're unused variables. That's perfectly fine. I wanted to see if they were going to argue about the code, but there's no syntax error in any of those. And of course, I knew there wasn't, even though I didn't do anything on it. So again, I'll just say Ted. All right, so that, and it says your name is Ted. So that was a-okay. So now we've got more variables now. So now on our assigned values, let's move the space here. So where are my variables? Okay, so step 2, oops, that's not where I wanted it. I wanted it here so that we can segregate 1 from 2 for you. Okay, so that and there. So now we have those, and then in calculations, we are going to have calculations this time. Okay, so we got the variables. Now I want to put in my well, we have to get the variables. No, we don't, because let's see, did I say I'm getting them from the user? Yes, I did, of course. Okay, so I've got to get the values from the variables. So I'm going to say that please enter whatever first, okay? And it's still going to be the sin there. So we need that, and then I'll go down and do mine at the end of that. So I'll take the next ones now. So that part is step 2. So coot, how many quarters, and then that to the nickels. So control copy that. And it's step 3. So again, up here, step 2, after that sin, control V again. Okay, and let's get rid of that space, not that that really matters. And I want to segregate mine from theirs, though, from the first one I just did, that. So now let's see if we run it. Okay, so coot, how many quarters do you have? C input, quarters, and I do have quarters. C in coot, how many quarters do you have? Yes. How many dimes do you have? Dimes, yes, I have it. How many nickels do you have? Nickel, oh wait, nickel. Let's see, quarters, God bless it. Nickel, did I have nickel down here? Okay. No, it was quarter, dime, and nickel, and then quarters, dimes, and nickels. So let's see, quarter, dime, nickel, yes. And then down here, okay, this one here may have been the problem. You can't have a no, wait a minute. Maybe I don't know what I didn't do. Let me see. Quarters, dimes, and nickels. We need that. But then we also have quarter, dime, nickel. So here, when I'm saying how many nickels do you have, I can't assign it to a constant. So I have to make this nickels. Stupid me. That may have been the whole problem. Let's see. All right. Yeah, that was the problem. God. All right. So Ted, just to get rid of that. So now, how many quarters do you have? I said 10, I think, for each, right? How many dimes do you have? 10. How many nickels? Oh, wait, no, I'll do it as 10 anyway. All right, so 10 for everything. So your name is Ted, all right? But I put in, so I captured in my variables now the quarters, the dimes, the nickels. And the reason I have pennies, see this comment? this is after the calculation. So the calculation is for pennies, how many quarters plus how many dimes plus how many nickels. All right. So those are done. And now my calculations. So again, there was one tiny error, but that one tiny error, it looks like it wasn't an error here. I don't know where the heck I put it. But anyway, 1 nickel should, oh, right there, right there. Yeah, that wasn't an error. That was nickels. Okay. Because otherwise it was trying to do a constant. You can't change a value of a constant. All right. So now my calculation, all right. So this one, and then my output, I assume now it's going to be all okay. Control copy. And then up here, so, oh, wait, now I'm going to put it here and then I'll cut the other one. Control V there. And then output. All right, so I already have the output. So step 3, so I don't need this one then. Your name is, I'll put that there too. All right, let's just go ahead and see what we've got now. All right, so run. All right, so now enter your first name. Now we shall say Professor. How many quarters do you have? 10. How many dimes do you have? 10. How many nickels do you have? 10. So now it says you have 400 pennies. Your name is Professor. So let's see how many pennies we have. So 10 is what we entered. See here it says 10. And what was the value? The constant is 25. So 10 times 25 is 250. Okay, so it's not 400, but remember, that's just quarters. So 10 times 25 is 250. Then we have 10 times 10 for dimes, because it says how many dimes do you have? 10. What's a dime worth? 10. So 10 times 10 is 100. 100 plus 250 is 350. And then we have how many nickels? 10. 10 times 5 is 50. 50 plus 100 is 150. 150 plus 250 is 400. So if you want this code, even though it was beautiful before, but sometimes you got to play with your code. And my code was perfect, but one little error, and it does show you the importance. One little thing down here on my C input statement, I had nickel instead of nickels. Usually the error syntax points you in a right direction very easily, but sometimes they can throw you for a loop. But anyway, if you guys want to take a picture of this screen to show you how to do that, you are welcome to. Let's see, quarters. Let's move this one down. Oh, this is a, okay. Let's just move that down here. And I'll put another slash. Okay. So that, and that. So let me let you guys then, you know what? I should probably just give it to you from my file, right? Where did I put the file? Is it this? Yeah. So the only error, yeah, this nickel here should have been nickels, all right? So you put an S here. I won't give you this as code, but you guys can take a picture of it so you can learn how to code. And again, some of you are already doing a great job, and you probably can. But so design an algorithm to convert the change given in quarters, dimes, nickels, and pennies. When you type this into a text file, do not hard return, because a slash means a single comment line. And if you do a hard return, then the next one is not part of the comment. All right. This will actually, you know, as long as you type it, then when it gets to the end, it'll word wrap. See, I'm using word wrap here, so I do have it on. But anyway, so you can take a picture. Let me try to make it as big as I can so that you guys can. All right, you don't need that. Yeah, so actually that one little page. Oh, wait. Where's my, oh, shoot, no, because I didn't put in all the little code. Let's see, that'll make it bigger. Yeah, let's see. All right, so instead of giving it to you from that, let me give it to you from here. What I'm going to do is make this wider, because we don't want those instructions. The instructions you're not using, okay? Let's see, how come that's not moving over more? All right, so that, we'll leave that. So don't take a picture of where it says instructions. How can I get rid of the instructions? Let's see, should be able to block that view. Can't. Instructions. Oh, wait, that? No. That says instructions. Oh, well. Anyway, all right. So take a picture of that if you want it, okay? And let's have you go down to line 27, and then I'll put down one extra space so that you don't, so that your code, wait, up there. No, not to 27, sorry. I want to make you get as much, yeah, right there. Okay. So take a picture of that. the screen from line 1 to line 26 is the code I want you to have, right? But as a picture, and call it picture 1 of 2, all right? So that's 26. Now, I want to get rid of 26, and then the rest, you don't need any of this because this was just my comment. So let's get rid of the comment. There, okay. And then that, and then that, and that, and that, and that. So let's see, 26 we need it. Wait, oh no, it's messed up now. All right, no, we went through 26. Okay, so then what's beyond 26? So now you can just do from 20, like from 30 really down, but if you want to get 27, that way you'll know there was nothing in 27. So if you did a picture of 1 through 26, okay, that's good. Now take a picture of, I can't get it to go up as high as 27, so don't take that part. Just make the picture from line 27 down to line 43, and you have the entire code, okay? And if your code, your picture includes this stuff over here, that tells you what I did in terms of how the code works. So then you just go back and look at it. Anyway, this video is way too long now, so I have to stop it. I hope you took a picture if you wanted it. I'll save this in here. Somebody remind me that it's programming exercise 2-9 in, I guess this is 5355. And that way, if I have to run it again for you, I'll be glad to. All right? All right. Excuse me. Have a great day. That's more than enough for Unit 1. My gosh. But remember what you got to do. Sorry, I said I'd show you the PowerPoint. So PowerPoint slides. I'm not a person to go through all PowerPoints. Oh, I already have my computer. I didn't need to do that. Mine. You're silly. Let's see. I don't know if I put them in my fall one or not. COP1334. Now this is old, but it's still the same thing. No, it's not in there. Fall 2022. COP. PowerPoint. Okay. So chapter 1. All right. So I think I told you that the chapter is only like 22 or 23, 24, 25 pages. It's definitely not many. I'm not going to read these, but I basically covered most of it anyway, just literally by looking at that summary page. Got it, whatever. All right, so let me see how many slides there are. Oh, there's 48. Are you kidding me? Wow, it's more than I actually, all right, thank you. It's more than I actually thought. That's on 111. I could do slideshow from beginning, but I'm not going to really do it, but I'll just kind of start it just to see. So that, and then just go down page by page. Okay. Yeah, that's exactly what I had basically covered, but in a shorter sense. Okay. I did not cover any early calculation devices, and they won't be on any test, but they could be conceivably on the Unit 1 quiz. So, you know, if you take it the first time and you notice one of these, then make sure you put it in a note for the second time. Mainframe is the old big computer, then mid-sized micro. I didn't talk about that either, really. I talked about CPU. I talked about main memory, secondary I/O, the brain to the computer, random access memory and main memory. I talked about that. I said main memory dies once you turn your computer off. Everything's got to be loaded in the main. I said, yeah, I covered all this. Yeah, all this I covered. Okay, well, most of it. I did example, right? So I did an example of that, and I showed you how to do that. And why I did it up to 210, and then I think I said that 220 should have been 1048, 576. In my case, it was 1055 or something. I just rounded. Here's a load statement. I told you a load statement in machine language, they use mnemonics. That's basically what the load is. And you see how it's 100, 100. And then so they're showing you that machine language is based to the zeros and ones, but I didn't go through all the stuff. Okay. Now you'll learn stuff like this in my next video because I'll be talking about chapter 2 at that point. Okay. And then this was here. All right. So, here, so they give you a little tiny example to run. Remember, when you use Replit or MindTap, it'll already have the pound include. If you use Replit, it won't have using namespace standard. So you just type in using namespace std semicolon after the pound include and before int main if you use Replit. Otherwise, instead of this coot here, you'd have to put std colon, colon, coot. Okay, and if you had a C input, it would be STD, the same spelling as this, STD, colon, colon, CIN, and CINs, remember, use greater, greater, as opposed to less, less, okay? And the return, and you must put in your main opening curly and a closing curly, but they'll both have that for you in their templates, all right? All right, and that sample run of this, of course, it's just a C output statement. So it's going to say my first C++ program. Anytime you do a string, you got to put a double quote before and after it. And then end L is the same as what I did with less than, and then I did a single quote backslash N. That's new line. End L stands for end line. There's a lot of things you can do more than one way. Anyway, all right, I hope you have a great day, guys, and I'll see you tomorrow. I apologize for the fact that it took longer than I wanted, but it is what it is, and I may not play it all in class because that's just way too long, but I'm going to stop my recording. Have a great day.